Hello and welcome to another video. In this video we're going to be working on build an array with stack operations. And in this problem you're given an array, target, and an integer n, and you have an empty stack with the following two operations, push and pop, and a stream of integers in the range of 1 to n, so you have to use them one at a time. And essentially your goal is to build up an array, like this target array here, by using these integers. So you start with number 1 and you want to figure out like what operations can I actually use. And you're basically only allowed to use push and pop. So in this first example, you have n equals 3, so you start with 1. So if you do push, so you would push 1, then you would go to 2, you would push 2, then you would pop 2, then you have 3, so then you would push 3. And that would give you the right array. And in the second example, we have 1, 2, 3, so this one's pretty straightforward. You just push 1, push 2, push 3. So essentially, every time you push the next number up. And then every time you always pop from the end. And for 1, 2, and 4 numbers, you would just push and push. And then you have what you need, and you would just stop. So you can stop wherever you want, but essentially you have to get this target array by using push and pop operations. And you want to return the operations, not the array. So you just want to return an array of operations. And so let's say we have some array, say we have some long array essentially, and let's figure out how we would do this. So let's say we have like 1, 2, 4, 7, 10 or something like this. And also it is guaranteed that there is an answer. You don't have to check for invalid answers. So in every valid answer, in order for this to be valid, you will have an increasing array with all unique numbers. So how would we do this with a target of, it doesn't really matter, right? As long as we have 10, we're good. So let's say n can be whatever, like 20. How would we do this? And it's going to be pretty straightforward. Essentially what you want to do is you want to simulate a stack, but you don't actually want to like store a stack. And then you want to just be looping. So the way this is going to work is like so. What we're going to do is we're going to have some kind of index into our target array of like the goal number we want. And then we will also keep track of the current number we're on. So we'll start at number 1. And basically what we're going to do is we can just keep doing this until we have our whole array. So we have some loop until we have our whole array of operations. And I'm going to, for pop, I'll just write O. And then for push, I'll just push U just to make it smaller. So essentially all we need to do is we just need to keep track of like what number are we on and what number do we need. And as long as our number is too small, what we got to do is we still have to like push it, but we can just push it and then pop it. And that way we're kind of like throwing it away until we get the number we need. So basically we have a loop till end of the array, right, of target array. And then we have to check the number we want. And if it's too small, just do push plus pop, which will essentially get rid of the number and then give us the next number. And then finally, when we have the number we want, so we can write it here. When we have the number we want, just push it. Then go to the next index, right? So this is pretty much what we want. So let's try to kind of follow this to get this. And it's pretty straightforward. So essentially what we're going to try to do is we're going to say, okay, we want 1, we are starting at 1, right? That's a starting number. If n is 20, we have to start at 1. So this is the number we want. So we're just going to push. So we're going to push, we're just going to write U. Okay, now we go over here. This is the next number we're on. Oh, it's actually doing this all in this color. So we push U. Now we're on 2. And by the way, since anytime we push a number, we will increment our current number, right? Because we have to go to the next number. So here we want 2 and we are at 2, which is perfect. So we'll just push the number again. So we'll just push and we'll increment our number. Then we go to the next index and we say, okay, we want 4, we have 3. So this is not the number we want. So we need to just like get rid of this 3. We don't want it. And we need to just increase this number. So we're going to push and then we're going to pop. And then that will help us increment the number. And then we are at 4, so now we have the right number. So we will push 4. Then we will increment the number. Then we come over to this index and we say, okay, well, we want 7, we have 5, so we want to just get rid of 5 and 6 somehow. You can get rid of them by just pushing and popping, right? So we're going to push and pop twice to get rid of 5 and 6. So push, pop, push, pop. Now we will have 7. That is the number we want, so we're going to push, increment. But yeah, it's basically you are just pushing every number, and then you are just popping every number that you don't want. Then we come over here, and we want 10. We are at 8, so we don't want 8, so we'll push, pop, push, pop. Then for 9, we will push, pop. And then finally for 10, we push, right? So remember, U is push, O is pop. And let's kind of try to simulate these operations and see if we did the right thing. So we start at number 1, so we push 1. Then we have the next number, so we push 2. So here, push 2, push 3, pop 3, push 4, push 5, right over here. We pop 5, we push 6, pop 6, push 7, push 8, pop 8, push 9, pop 9, and finally push 10. And so this would be our array. So we have 1, 2, 4, 7, 10, which is correct. So that's pretty much all it is. It's kind of like a hard or easy problem. Essentially, all you do is you just look at what number you need, and if your number is too small, you just push and pop, and that'll get rid of it and increment the next one. We have to use every number, and then once we are at 10 and we say, okay, well, our target is matching, then we just stop, right? So we need to have one loop that checks, do we have every number? And then we need to have some kind of inner loop to check, are we on the number we want? And if we're not, let's just do a push and a pop to increment our number and not record this entry. And yeah, that's pretty much it. So now we can code it up. So essentially, we're just going to have an index, which is the index in the target array. And then we'll have a cur, which is like the current number we're on. And our result array of push-pop operations. So we could say while index is less than length target, meaning like we still need some numbers, right? So whatever index in the target we are at, we can just say while our current number does not equal the number we want, let's just do a push and then a pop to get rid of that number. So we could say res append push, res append pop. And now that, oh yeah, we have to also increment our number, right? So we just use that number, so we'll increment. So now we have the number we want exactly where we want it. So now all we need to do is push. Push. And then now that we matched up our number with the number in the target, now we have to move on to the next number in the target. So we will say index plus equals 1. And we have to increment our number again because we just did a push. Every time you do a push, you have to increment the number because you can't push the same number twice. So finally, now our array is going to have all of our operations. Essentially, this is the skip operation where we skip a number, and this is the operation where we actually want that number saved in the array. And now we will return that result, and let's see what happens. And I think we have a solution. And there you go. So this is basically as efficient as it gets, and we can talk about the time and space here. And essentially, let's think of, well, what can happen, right? So obviously, in order to have a valid solution, worst case scenario, this doesn't really depend on the target length. This depends on n, because worst case scenario, our last number in the target is n, right? So let's say n is like 1,000. It doesn't really matter how long our target is. If the last number in our target, if target has some numbers, but then the last number is n, all right, like 1,000, it doesn't matter the length. We're still going to have to push and pop 1,000 times, basically. So it doesn't matter how long the target is, as long as we're getting valid results, it's actually going to be O of n, not length of the target. Because our target can be two things, but if it's like 1 1,000, we still have to do 1,000 pushes and pops. Or it could be 1 to 1,000, this would take the same amount of time. Okay. Yes, that's for the time. And for the space, so we don't really use anything other than the result. It's O of 1. We didn't actually build a stack. I was originally thinking like maybe I need to build a stack, but you don't really need to build a stack. You can just keep track of like the index you're on and simulate a stack instead of actually building it. And it's not too bad. Because yeah, like there's no point in building a stack. We're basically just keeping track of do we have the number we want? If we do, let's move on to the next number and let's go through all the numbers in the target and do it that way. And yeah, that's going to be all for this one. So if you did like this video, please like it and please subscribe to the channel. It helps grow it a lot. And thanks for watching, and I'll see you in the next video.